I show here the online plotter for the face portrait. Okay, before this, we learn sketch the directional field for one ODE. So now is the system topic. We also can use this plotter in sketching the face portrait for linear system and also the non-linear system. So we have two equations. We have to type both equations here. For example, the first equation dx dt, and then the second equation dy dt. We type in this plotter we have to use x and y. Okay. Variables here means that the graph that we will sketch. So if we choose y versus x here, then in the face portrait here means we have the vertical axis as y and the horizontal axis will be x. So example for this system, okay, I type in the equation. So we will get this form. It's face portrait. Okay, at the beginning actually you will have only the arrows without the line, the colored line here. Okay, but once you click on anywhere here, there will appear the lines. So for this system, actually, if you solve it using eigenvalue method, you will get its eigenvalue equal to 0.02 and negative 0.07. So this case actually, the type of eigenvalue that we have is one positive value and another one is a negative value. So about the analysis that we've learned before, we can check its stability from the stability table. So here one positive, one negative. Based on the stability table, it is unstable. Okay, if I'm not mistaken, please check. Previously we see the analysis in general. So here based on the face portrait, we also able to analyze. So as what we can see here, let's say we take this region. Okay, this region is x and y positive. Okay, x positive, y positive. So what is the meaning of this face portrait? It means the arrow actually means that the increasing t. Okay, so if we see in this region, the arrow goes downward here, then it move to the right. Okay, means that it will begin with certain value. That value is actually the condition, the initial condition. So here x and y, actually I take this question from one question from the assignment that I gave you. I think this is about the cash in account A and account B, something like that. Okay, so let's say the account, the initial cash in that account is for x is 100, for y is 10. Okay, so means based on this graph we have somewhere here. Okay, let's say from here. Okay, so means that its original position is here. The cash in account for x it is 100, for y it is 10, for example. So as time increases, we will go along this line. We see that it is decreasing. Okay, it goes downward, means we can say that downward means y is decreasing. right? Y is decreasing. Then at certain point we see here actually as Y decreasing, we see X. Okay, the arrow we see it's move toward to the move to the right. Okay, move to the right slowly, beginning from here. Then at certain point, it looks like y approach 0, right? And then for x, it increasing infinitely. Okay, so means that the cash in account representing by y, it decreases, okay, and reach maybe close to 0. And for account B, the second account that is represented by X, okay, we see at first it increase slowly, and then after some time it increasing, okay, exponentially. Okay, so this is reflected by the general solution that we have seen previously. For the eigenvalue 1 positive and 1 negative, we see in the general solution we have one exponent positive and another one is exponent negative. So if we split the solution that we have before is x and y. So if we split, then we have its general solution. We can relate the general solution with the finding from this phase portrait.